Welcome to Messy Math Moments Matter, where we explore experiences to help students engage in math more deeply. When we allow opportunities for math to get a little messy, we will see big results. Don't worry about it being perfect. Math class should be perfectly imperfect, just like this video. This video will focus on multiplication of single-digit numbers. This is from grade 3, organizing idea number, learner outcome number 3. Students analyze and apply strategies for multiplication and division within 100. So I've gone through the program of studies and I've looked at the understandings, knowledge, and skills and procedures for the 3 levels of understandings listed within this learner outcome. And I've highlighted the ones that I felt that I would deliberately focus on for this particular set of experiences for students. That doesn't mean I won't deal with the other ones as well, but I might only be focusing on them a little bit or unintentionally, whereas the highlighted ones in yellow, I'm deliberately focusing on. So this understanding is quantities can be composed and decomposed through multiplication and division. And there are the knowledge and skills and procedures that you would know and do in order to develop that understanding, in order to build towards that learner outcome. For the second row of understandings, this one is focusing on multiplication and division strategies can be supported by addition and subtraction. And the third row of understandings is multiplication number facts have related division facts. I'll link all of these within the experience document provided. There's a couple of things I want to clarify about this particular outcome. Number one of the cusp states that students will multiply and divide within 100. Now, students in grade 3 are only focusing on factors up to 10. So 10 by 9 is fine, but 11 by 3 is not within grade 3 curriculum. That's actually a grade 4 outcome. So keep that in mind. Single digit multiplication works, 10-digit works, but any factor beyond 10 does not fit within this curriculum. The second clarification I'd like to bring to your attention is that one of the cusps states that multiplication is repeated addition. Yes, often we can solve most multiplication questions using repeated addition if they're whole numbers. But in grade 6, when they get to 3 1/10 multiplied by 5, sure, you can do a little bit of repeated addition. You could repeatedly add 3 1/10. But then you get to a higher grade where they're multiplying a decimal by a decimal, and that just doesn't fit. So I try not to say repeated addition is multiplication or multiplication is repeated addition. But what I will say is that multiplication can often be solved through the use of repeated addition. So just a tiny tweak to the wording. The third piece I'd like to bring to your attention is the language use. So often we will say 3 multiplied by 2 means 3 groups of 2. And what that does is put students in the frame of mind of drawing 3 circles and then 2 dots in each circle and then counting the dots to find the answer of 6. So we're getting back to a count all, maybe some skip counting to solve a multiplication question. It's not where we want students to live, because if I'm doing 3,495 multiplied by 4, you wouldn't want them drawing all those circles or all those dots. So we can tweak that by saying 3 multiplied by 2 could be described as 3 groups of 2, but there's better ways of saying that. And I'm going to be using the phrasing 3 2s throughout this video. Often we will give students multiplication tables that are completely filled in. And what we've trained them to do is if they're multiplying 5 multiplied by 3, they put their finger on the 5, their finger on the 3, and they bring their fingers together, and then the answer just miraculously appears there is 15. They don't really understand why it's 15. So we're going to use an empty multiplication table today to explore multiplication as arrays. We want to make sure that we give students a variety of experiences using multiplication, a variety of manipulatives, variety of models, because what we want to do is we want to build that connection of multiplication and division in a variety of contexts so that it becomes so intertwined that it's hard to lose it. Rote memorization, flashcards, things like that, they might give us a quick return on reward, but they don't have lasting effects generally. Some students they do, but not all students. But the slower, the longer we take in order to connect those facts, the more likely it is students will keep those facts forever and ever. So for this set of experiences, you will need a centimeter grid multiplication table. And it's really important that that multiplication table is exactly centimeter based, otherwise this won't work. Sometimes what happens is when we send it to the printer, the photocopier, it adjusts it slightly and puts it out of scale. Or if I take one that is in scale and run it through the photocopier, sometimes it'll put it out of scale then. So it's super important that you double check before giving this to students. The second thing that you'll need are relational rods. With the relational rods, because these are centimeter based, I will just take them and put them on my grid and just check a couple different places to make sure that it stayed as centimeter by centimeter. Now, what I do tell students is that sometimes because they're plastic, sometimes the measurements will be out a hair, a millimeter or so. That's fine, as long as it's not significantly over. Then that's an issue. So let's begin. First thing I would have students do is use the relational rods in order to count. So there's 1, 2, 2 2s, 3 2s, and they'll just keep going. 4 2s, 5 2s, 6 2s, 7 2s, 8 2s, 9 2s, 10 2s. Okay, we'll clear that off. We're going to do the exact same thing, but this time we're going to add the word value to this. So 1 2 has a value of 2. 2 2s has a value of 4. And if I'm not sure why, I could use my 1s in order to do that. And count them up. I could lift this up and see I've covered 4 squares. Completely up to me. So 3 2s has a value of 6, 4 2s, 8, 5 2s, 10, 6 2s, 12, 7 2s, 14, 8 2s, 16, 9 2s, 18, and 10 2s, 20. We'll clear that again. This time, instead of using the word value, I'm going to start adding an area, but I'm also going to write down the area that I'm stating. So 1 2, when I cover this has an area of 2. When I move this out of my way, I can see 1 2 there, and it covers 2 squares. So we will put the 2 here to say from here, the start to the end, it covers 2 squares. And I'll just put that back there for now. 2 2s, when I put that on there, well, that has an area of 4. So I'm just going to move it over to the side for now. 1 2, 2 2s has an area of 4. 3 2s, 1 2, 2 2s, 3 2s has an area of 6. Now, a student might just start building on the side so they don't have to keep moving it out of the way. 4 2s would have an area of 8. 5 2s would have an area of 10. Notice I'm saying 5 2s has an area of 10. 6 2s has an area of 12. 7 2s is 14. 8 2s is 16. 9 2s is 18. 10 2s is 20. Now I'm going to ask a really important question in math, one we should be asking all the time. What patterns do I see? So they're going to talk about every second number, counting by 2s, even numbers. They might say all the odd numbers are the ones we didn't write down. Those are important those are important patterns for them to see. Now, I might split this next part onto another day just to keep these lessons short and sweet, because we want to slow cook the math. We don't want to rush it. or I could do it on the same day. It all depends. So I might say to students, if I was trying to figure out how much 10 twos were, I might go 2 plus 2 plus 2. And I'd have to write out 10 twos here. And when I was done, I could say 20. But if I was trying to do that, I might goof and I might accidentally write too many twos or too few twos, might get a little confusing. So mathematicians have another way to show 10 twos. Just going to move this up a little bit so this image doesn't get in the way. So a mathematician could write 10 twos has an area of or has a value of 20. Well, let's start at the beginning. 1 2 has an area of 2. 2 twos has an area of 4. And students are simply going to record on their sheet how many twos and the area, but written as a mathematician would write it to help keep track. 5 twos is 10. We would talk about the importance of drawing our multiplication symbols nice and neatly, because if we drew it messily, it might look like an addition symbol, and that wouldn't be very good. We need to write neatly so that everybody can read what we wrote and learn from it. And there's my 9 twos equals 18. When we're done, again, I'm going to ask a very important question. What patterns do I see? What relationships do I see between what I built, what I wrote here, and what I have over here? So the next thing I might do is ask students a puzzler. How many twos would I need to have in order to have an area of 10? So I want an area of 10. So I might say, oh, there's a 10. I might build it. I might skip count my way up to it. Lots of options for students to figure this out. But they would say, oh, you need 5 twos in order to have an area of 10. So I would let students know that a mathematician would write this as 10 divided into twos. I would need 5 of them. 5 twos gives me an area of 10. So I'm starting to introduce that inverse nature of multiplication and division. So I might ask another random one. What about 16? How many twos would I need to create an area of 16? And they'd figure it out however they did it, and they'd say, oh, I would need 8 twos. Well, we would write that as 16 divided into twos. I would need 8 of them. 8 twos gives me an area of 16, and have that conversation. Then students can go ahead and fill all of that in as well. I'm just going to pause the video here and go ahead and fill these in. So now I can ask students, what patterns do you see? What relationships do you see? And they can talk about how there's a 1, a 2, and a 2, a 2, a 2, and a 1, a 4, a 2, and 8, 8, 2, and 4. They can talk about how the multiplication is the piece that's different, the order is different, but they're reverse orders, things like that. Lots of options for them to talk about there. So now we'll start again. Again, this might be another day. So we started with 1, 2, like this. What if I wanted to build that only using green ones? How many green ones would I need? And students would build right on top. Oh, I need 2 ones in order to build something that is the same area as that one, as my 1, 2. Well, let's record that. I would need 2 ones, and that gives me an area of 2. What if I had 2 twos? So I'm looking for a rod that would give me same thing, but the rods I'm going to place are vertical. It's kind of hard to see when I did it with the ones to start, So I'm going to help students with this one. So if I place the blue one vertical, I can see that it matches up this way. And I would need two of them to have the same area. So 2 2s gives me an area of 4. What if I have 3 2s? What rod can I place here vertically so it has the same length? And how many would I need? Well, it might take them a bit, but I'll put their 3 there and their 3 there. So 2 3s will give me the same area as this one, which has an area of 6. And then students will just keep going. So there's 4 2s, and I would need 2 4s to be able to match that. So 2 4s would give me 8. Okay, add another one. And now there's my 2 5s. 2 5s. And they'll just keep going until they are completely finished building this. And I bet you can figure out what my question is going to be. What patterns and relationships do you see amongst all of these representations? So now I could ask the question, if I wanted to build an array of 10, how many 5s would I need? So then a student could figure out, well, if I'm only allowed to use 5s, I would have 2 5s. So a 10 divided into 5s, I would need 2 of them. 2 5s is 10. 10 divided by 5 is 2. And I will do that for all of these. I'll do a couple example ones. So I might have them build the 16 divided into 8s. I would need 2 of them. I'll figure out pretty quickly you always need 2 of them in this case. And they'll just go ahead and fill them in. And of course, I'm going to ask that same question, what patterns, what relationships do I see amongst all of these representations? And I just noticed that that should be a 20. I hope you caught that. And there we go. Perfectly imperfect. So I can repeat this exact same process, but instead of doing 2s, I'll do 4s. So there's 4s that I'll build this way. Then I could do 6s, 8s, 10s, working on those doubles. Then I might do 3s, 6s, and 9s. Then I might do 5s and 10s again. After I've done all of that, then I can do, instead of going horizontally, build my 1 2, 2 2s, 3 2s this way. But again, repeat that exact same process. Do my 2s, do my 4s, do my 6s, and so on. So you've got a lot of bang for your buck with one set of very simple experiences. If you have any ideas for future Messy Math Moments Matter videos, please feel free to share them. I look forward to seeing you in the next one.